This video is to go over homework 3C, lesson 311, problem number 2. A, it says find the height of an equilateral triangle with side of the given length. So part A, we have equilateral triangle. That means each side is 1 centimeter, and your job is to find the height of this. So for this one, if you drop altitude from the top vertex to the base, then you are splitting this triangle into two right triangles. So here you'll get triangle like this. The hypotenuse is 1 centimeter, and the base is half centimeter. And then if you draw, as you know, we can use Pythagorean theorem. We can make a square out of that, of each segment. And again, the area of the smaller one plus middle one should be the biggest one. So the area of the smaller one will be half times half, which is 1/4. The biggest one is 1 centimeter times 1, so it has to be 1. So the medium one has to be something. And if you take a square root of that, that would be the length of the height, and use that concept. So problem number 3 and 4 is kind of related to problem number 1. Problem number 3 is find the pattern out of that. So look at the answer of part A, B, C, D, E for exercise number 2, and find the pattern and write the rule. And once you write the rule, you write that in mathematics, so that that's going to be the formula. Formula for the to find the area of the equilateral triangle. 5 is to find out the segment. So if you look at the first triangle, which is 1 by 2 legs are 1, and the length of hypotenuse will be square root of 2, because you can get the square, which is area of the which is the area 1 square units, and the other one will be 1. So the biggest one will be the area of the biggest square will be 2, and take a square root of 2. Therefore, the length of the hypotenuse of the first triangle is square root of 2. The next one will be, the second one will be, the height will be square root of 2, and the base is 1, so that's and also that's right triangle. So you can make the square, if you make the square with the height, will be 2, because square root of 2 times square root of 2, and the smaller square will be 1, because 1 by 1, so the largest one will be 3, therefore the height will be square root of 3. So follow the pattern and find out. So the next one, it's easily find that out easily. We can guess that the length will be square root actually 2, because square root of 4 equals 2, but show that that actually is square root of 4. And once you start showing that, you can start seeing the pattern, and make sure to show the work, so that I'll be convinced with your understanding. Problem number 6, that's gonna be, we're gonna have to find out. So we have a cube with 10 units, length, width, and the height is 10 units, and we have to find out the distance from one vertex to the opposite vertex of that. Kind of have to find out the squares or triangles we are looking at. So let's say we take that, and then also we take the diagonal, so that we have a slice of triangle. So we have a triangle which is right triangle, which has the height is 10, and that base is the diagonal of the square. So in other words, this distance from here to here, the diagonal is the distance from, it's a diagonal of a square. So we first have to find the distance from distance of the diagonal of the square, which is 10 and 10 here, and therefore using the same pattern, you gotta find that out first, the distance first. Once you find that, now use the Pythagorean theorem, make a square and make a square, and add these area of two squares together to find out the area of the biggest triangle, a square. And once you find the area of that square, if you take a square root of that, make sure to simplify, then you'll get the distance, the length of the hypotenuse of or diagonal of the cube. Problem number 7. The airplane leaves Los Angeles, which is LA. Okay, it flies 100 miles north. So usually north is the top. So you go there, 100 miles, and then it turned to the east and flies 600 miles, and then it turns north again and it flies 350 miles. So what's the distance from the starting point? So what's the distance from the starting point to the point right there? So so the hint here is you can actually make a triangle like this, so that's we have a triangle, so starting from LA, go to the east and travel to 600 miles, and from that point you can go to the ending point right away, and that's gonna be the straight line, or straight line, and it makes triangle. It makes right triangles. So we can use Pythagorean theorem from here. Problem number 8. What's the area of the plot of the land shown in this diagram? State any assumption you make. So how do we find the area of this? Maybe we can assume that this is 90 degrees, or we can probably assume that this line and this line are parallel to each other, although it didn't say it. But if you state that assumption, we can say that this diagram is trapezoid, and once we know this is trapezoid, we know how to find the area. So problem number 9, find the area of triangle ABC, and we know if we could find out the length AB, then that's going to be the base, and we can use the height 8, and all we have to do is that the length of AB times 8 divided by 2, that's going to be the area of this triangle. However, we don't know the base. But if you cut that perpendicular line from the base AB to the vertex C, then we can have two triangles, which we know the height is 8 and the hypotenuse 10. That's a smaller one, and the biggest one will be the height is 8, but hypotenuse will be 17. And we can use Pythagorean theorem to find out the missing one, and if we add these together, that's going to be equal to the length of AB. So we can start from there. Problem number 10. Problem number 10 is saying that find the Pythagorean, look back through your work in this section and find two other Pythagorean triples. So for example, 3, 4, 5 is Pythagorean triples because you can have a right triangle which you have three. The one leg is 3 and longer leg is 4 and the hypotenuse 5 units, because if you make a square out of it, the biggest one will be 25, which is 5 square, and the middle one is 16, which is 4 squared, and the smaller one is 9 because 3 squared. So 3 squared plus 4 squared equals 5 squared. And in this section there are two other Pythagorean triples. What are they? Problem number 11. The following triples are members of family of Pythagorean triples. There are other Pythagorean triples that do not belong to this family. Check that each triple listed below is a Pythagorean triple. How are these triples enough alike to justify calling them a family? So these 5 triplets are actually related. How? Or we know 3, 4, 5 from previous problem is a Pythagorean triple. How can you show 6, 8, 10 are Pythagorean triples? Well, you can say, okay, let's have we have right triangle with 6 unit and 8 units and hypotenuse 10. How do you show that this is actually Pythagorean triple? If you do that, if you do the way that I did in problem number 10, that's gonna be, if that works, then this is gonna be the Pythagorean triples, and show that to all of them. And after that, why they call these are these are members of a family of Pythagorean triples. Problem number 12. Draw a triangle with the following side lengths, and what do the triangle have in common? This is kind of related to what we have in problem number 11. So let's look at part C. So we have 15. The longest one is the hypotenuse, and the other one is the shortest one is 15, and the medium one is 20. So if this actually works, then 25 square should be equal to 20 square plus 15 squared. But we're not sure if this is true. No? So if you make the square out of that, it should be true if these are Pythagorean triples. And once you find that, what will be in common? To explain. Problem 13. Which of the following does not belong to the same family of Pythagorean triples? So at this point, I hope you understand that you find out why we call a family of Pythagorean triples. So Pythagorean triples has are the 3 numbers that satisfies Pythagorean theorem, but inside of those triplets there are families, and there are reasons that we call families. So for example, 3, 4, 5 is Pythagorean triple, and 6, 8, 10 are another Pythagorean triples, and that belongs to 3, 4, 5 family. And another example is 5, 12, 13 is Pythagorean triples because 13 square is 12 square plus 5 square. But these number doesn't belong to 3, 4, 5 family for some reasons. What is the reason? And I want you to find out, look at 4 triplets on problem number 13 and tell me which one belong to a family, which one does not belong to the same family of Pythagorean triples.